So nice to meet you all, and thanks for inviting us today here for the session. I would like to explain a little bit what the company which I'm working for, Sony DADC, is doing, where we are coming from, and then explain how we want to contribute to the especially automotive world, but also what we intend to bring in with our development. So next slide. Okay, sorry. So basically, the company exists already since 40 years in Austria. We are, as you can see here, we are the part of the bigger Sony family, which is, of course, very well known worldwide. And as such, part of this company, we have a footprint in 3 countries, 2 out of which are in Europe. So besides our headquarters in Austria, we have another production facility in Czech Republic, and we have another location in the US. Our major product range portfolio is tied to our colleagues which are delivering the PlayStations into this world, and we are delivering the data carriers for this in the moment is our UHD, so ultra high definition data carriers. We as a company produced more than 26 billion products until now. We have around 1,000 employees globally, and last year we delivered around 300 million products to this area. Now, if you ask yourself why is such a company which produces CDs, DVDs and Blu-ray discs here, so Sony is a company which is very socially aware and tries to keep their business alive for longer periods, so to also reduce the CO2 footprint, but also ensure working places. And 5 years back, the company started to investigate why, because our product portfolio is shrinking. The company started to investigate how and where we could contribute in the future with our production processes and with our capabilities. We figured out that micro-optics would be a perfect match, and this is where we started to work with our partners. So from our manufacturing capabilities, which you can see here also a little bit, and the capacity to work successfully in the optical area with polymers, we created first samples, which you can see here in the middle. And these samples you can also see at our booth here. We created first micro-lens arrays, which work perfectly fine. And we are looking also into the future how to develop further products, not only for automotive, but we started with automotive. Basically, what we offer is we have an optical design capacity in-house. We have the capacity to produce our own masters and nickel chips for the replication. We work, of course, with several partners on this to improve our capacities as well. Then we have the wafer replication also in-house. We are working on the optical metrology for our new products, and finally we can do the handling and packaging in all 3 of our locations. This all together delivers the unique fabrication technologies, and if you heard some of my colleagues who were speaking about micro-optical technologies in automotive, I think you could figure out that until now the biggest factor to not let micro-optics in automotive technology become one of the major trends in terms of volumes and sizes is that this technology is still very cost ineffective or very expensive, with other words. We, as a manufacturer who delivered roughly 26 billion products until now, want to change this on 2 levels. One level is, of course, using our polymers as a base substrate, which will reduce the cost from the material side. The other way is, of course, using our capacity to manufacture in big volumes and do this really on a daily basis so that we deliver really dozens of products with one shot. As you can see here, our production facility located in Austria is fully automatized. This is also valid for our new production line, which is going to be fully ready to run by early next year. And besides our capacity for injection molding and nano imprint, we have also the capacity to fully automatize check our products and pack them. Basically, you can see here that we developed our product with the hole in the middle, which is roughly 120 millimeters of size. We developed this as a polymer wafer, and we achieved very good results with the structures which we are building on these polymer wafers in the same exactness and precision like our competitors in this area are doing on the glass substrate. Basically, you can see also, if you have some time later, we would like to greet you at our booth. You can see also these examples in real life. So you can see here one typical MLA, which is also showing all the USPs which we bring to this part of the business right now. And of course, we want to develop our portfolio not with MLAs only, but also go into other applications. Finally, to show a little bit, and as my colleagues already showed, a lot of applications which are in use today or are going to be used today, I will let my short video speak more about this, and hopefully if you have some questions, then I will be able to answer them afterwards. So basically we talked about safety relevant applications. So you see here that projections of the car when the car is driving are coming more and more, especially as the autonomy of driving cars will take over. This is also safety relevant not only for the driver but also for the environment, so that also the following traffic sees that the driver changes the direction, stops, or whatever happens. Right now, we see also some decorative applications which can also be used for commodity like here. And finally, when you see that right now the GTB is talking about this projection signal turn indicator right now, this is something which is also, I think, very actual in the automotive. So thank you very much again.